Welcome to the discussion. Today we're exploring two fascinating papers that delve into the world of large language models, LLMs, and their potential to revolutionize scientific research. The first paper, The AI Scientist, details a fully automated system for generating scientific papers. What's the big idea here?
The core concept is to leverage the power of LLMs to automate the entire scientific process, from generating research ideas to writing and even peer reviewing papers. Imagine an AI that can independently conduct research, execute experiments, and communicate its findings. That's what this paper aims to achieve.
That sounds incredible. But how realistic is it to fully automate such a complex process? What are the key components of this AI scientist?
The AI scientist relies on several key components: LLMs for idea generation and writing, a coding assistant to implement the ideas, automated experiment execution, and a novel LLM-based automated reviewer. It's a multi-stage pipeline designed to mimic the human scientific process.
And how well does this automated system actually perform? Does it produce publishable quality research?
The results are quite impressive. The AI scientist generated papers that, according to its automated reviewer, exceeded the acceptance threshold for a top machine learning conference. While the papers aren't perfect and often have minor flaws, the approach demonstrates the potential to significantly accelerate scientific progress.
That's amazing. But what about the second paper? Sparks of Artificial General Intelligence, Early Experiments with GPT-4. What does this paper explore?
This paper explores the capabilities of an early version of GPT-4, arguing that it exhibits traits of artificial general intelligence, AGI. It goes beyond standard benchmarks, showcasing GPT-4's abilities across diverse domains like mathematics, coding, vision, and even understanding human emotions.
AGI is a pretty loaded term. What makes this early version of GPT-4 so special, and what are the implications of such a system?
The authors argue that GPT-4's ability to tackle novel and complex tasks across multiple domains, often at or exceeding human-level performance, represents a significant step towards AGI. The implications are vast, ranging from transforming various industries to raising ethical concerns about potential misuse.
Let's shift gears and talk about the Sparks of Artificial General Intelligence paper. It presents a fascinating case study of GPT-4's capabilities. What's the author's main argument?
The authors argue that GPT-4, even in its early text-only version, displays remarkable general intelligence. They demonstrate this by testing it on a wide range of tasks, going beyond typical benchmarks to showcase its abilities in diverse fields.
That's a bold claim. How did they go about evaluating GPT-4's intelligence, given the lack of a universal accepted definition of AGI?
They took a more qualitative approach, focusing on novel and challenging tasks designed to test GPT-4's reasoning, planning, and learning abilities. They also probed its limitations and biases.
Can you give us some examples of the tasks they used to test GPT-4?
They tested GPT-4 on tasks spanning mathematics, proving theorems, solving complex problems, coding, solving coding challenges, generating code from natural language descriptions, vision, generating images from text descriptions, and even understanding human emotions and intentions.
And how did GPT-4 perform on these diverse tasks?
Remarkably well, often matching or exceeding human performance. For example, it passed mock software engineering interviews on LeetCode, wrote proofs in the style of Shakespeare, and even generated complex animations in Python.
Impressive. But the paper also highlights GPT-4's limitations. What are some of its weaknesses?
The authors point out GPT-4's tendency to hallucinate, fabricate information, make calculation errors, and struggle with tasks requiring long-term planning. These limitations, they argue, are potentially inherent to the autoregressive nature of the model's architecture.